everyone, and welcome back to Lowell Observatory's interactive stargazing. If this is your first time, welcome. Tonight we're going to be looking at a whole bunch of super cool objects through our new Cam DS26C tech. Basically what that means is we have this new fancy camera donated to us by Cam. And we're going to be using our plane wave telescopes that has this camera hooked up to the back of it to take these exposures of different objects in the sky live for you tonight. And so right now we have pulled up our main object for tonight, or our first object, I guess, that we're going to talk about, which is NGC 1999. And so this is a really tiny reflection nebula. So this nebula is in the constellation Orion, and the whole reason why we can see this nebula in the first place is because there is a variable star called V380 Orionis that is really, really bright, and it's basically lighting up the nebula. So that's what a reflection nebula is. It's basically just reflecting light off of from this star, reflecting that light so we can see it. So I think it's super cool because you can kind of see this dark triangle, like spiky shape in this nebula. And so that is that really dust-rich part of the nebula. So nebula also means, gas and dust that's just up in space. And so this nebula, or this gas and dust, some of it is thicker than others. And so the really thick region is black, looks black to us because it's so thick that light can't get through it. And so we get that cute little triangle area there. So I think it's a really neat object to start off with tonight. I don't think we've ever looked at this one before in interactive stargazing, so one of the first. And so tonight I'm going to go over a whole bunch of different objects, and so I just want to really quick go over what these objects are called and like what their name comes from and things like that. So we're going to go to one different object while I explain this. So let's go to NGC 281, or the Pac-Man Nebula. So while we're moving over here, let's talk about what NGC stands for. So NGC stands for the New General Catalog. Basically what that is this a huge catalog of different objects in the night sky. So they could be stars, they could be star clusters, they could be nebulas, they can be galaxies. Before, I used to refer to it as the New Galactic Catalog. I think I was projecting what I wish it was, just a whole bunch of thousands of galaxies that we have in this catalog. But there are a bunch of galaxies in it as well as other objects. So that's what's really cool about the NGC catalog, or the New General Catalog. There's some other catalogs that we're going to be talking about tonight. So like the Messier catalog, or an object might be called like M1 or something like that. So Messier just stands for Charles Messier. He was the one who came up with this catalog. He was a comet hunter, and basically every object that he found that wasn't a comet, he wrote down M1, M2, Messier 1, Messier 2. And so there's not just these two, those are the pretty popular ones that we'll be looking at tonight, but there's a whole bunch of other catalogs. It's like IC, which stands for the Index Catalog, a whole bunch of different other ones, but the main popular ones that we use are NGC and Messier. So there's some background for you. And so now here is our Pac-Man Nebula. So this is a bright emission nebula that is in the constellation Cassiopeia. So you can kind of see it, just a little bit of like reddish, purpley in the center of the screen there. And so that is the emission nebula. And so this one's a little bit different from the reflection nebula because there isn't really a star that is shining off of the nebula. What's happening with this one is the gas is being excited and it's being ionized, and so we call these H2 regions. So it's just basically excited hydrogen, and so that's why we can see this one instead. So this one is about 9,000 light years away from Earth. So really big emission nebula that we have there. All right. So let's start with some requests. And so another cool thing about the interactive stargazing, if you've never been to it, is we take requests and we'll show you the different objects that you request and if they're up or not. So we have a request for M42 or the Orion Nebula. So let's go to that one just because it's such a beautiful nebula. It's a really good one to kind of drill in the idea of gas and dust. You can really see it very clearly. And so the Orion Nebula is a stellar nursery in the constellation Orion, of course. So there's these little tiny baby stars that are being formed in this nebula. So this big cloud of gas and dust, it's so thick that it actually collapses upon itself in these little regions and start nuclear and stellar fusion to make these little baby stars. And so you can actually see those baby stars being formed in the center there because of how bright it is. And so those baby stars, they're so young and they're so bright and they're so energetic that they're lighting up the nebula. Again, gas and dust, and you can really see kind of like the filaments and everything in there. And so we have different colors, we have blue, we have red, and so kind of like the Pac-Man Nebula, we have, you know, these different colors, and so that basically represents what that gas is made up of. So mainly like hydrogen and helium and oxygen, and those things is what these nebulas or these stellar nurseries are made from. Well, this is a stellar nursery, not all nebulas are stellar nurseries. So that's why, again, it's really bright. And another thing with these young little baby stars is babies like to throw tantrums. They're super, you know, energetic. And so these baby stars also throw tantrums, and these tantrums, we call them stellar wind. So this wind is kind of blowing out the nebula and it's kind of making it diffuse. And so that's why we kind of get this bowl shape, is because those little baby stars are being formed and then they're blowing away the nebula to kind of make it in that bowl shape. So really beautiful object, and definitely one of the best ones in the sky tonight, I would say. Okay, so next up, let's see what else we got. Okay, so we have a request for Mars. So Mars is a little bit different because it's not a nebula, it is a planet. And so just a few months ago, I believe it was around November, it might have been a little bit earlier, a little bit later than that, but Mars was at opposition. So basically what that means is Mars was closest in its orbit to planet Earth. And now it's getting a little bit further away since it's, you know, past that time. And so back then we could actually see surface features on Mars. We could see the basalt flows, and we could on some nights see the polar caps. But now that it's getting a little bit further away, it's just going to look like a little tiny orange dot. But I still think that's super cool because we're looking at this planet from Earth. And if you guys heard the news recently, just on February 18th, we actually sent another rover to Mars. So now we have Perseverance, or Mars 2020, going on the surface of Mars and doing some really cool science. And so there's some really, really cool pictures that JPL and NASA has been releasing of Perseverance, and some pictures of Mars that it's taken from its cameras. So I recommend looking those up because they're super, super cool. So there is Mars tonight. I don't think we have too many other planets up tonight. So this is one of the only ones. Okay, let's see. Okay, so let's go to M31. So we'll do the Andromeda Galaxy. So the Andromeda Galaxy, this is a really cool one. So we're gonna do it now just because it's getting pretty low in the sky for us. So while we let this picture load here, Andromeda Galaxy is the closest major galaxy to us. So we have some smaller galaxies that are a little bit closer to us, which are the Magellanic Clouds. But this one is the closest really big galaxy. And so the Andromeda Galaxy is very, very similar to the Milky Way galaxy. It is a spiral galaxy. It's around 2.5 million light years away. So it's really far away. I mean, it's millions of light years away, but you can still see it with your naked eye in the sky. So if you go to a dark sky city or a place where you have really clear skies and you look up in the constellation Andromeda, you can actually see this little smudge of the Andromeda Galaxy. So I think that's super crazy that although it's so far away because of how massive it is, you can actually still see it with your naked eyes up in the sky. So I love this object. And so again, I was talking about how it's similar to the Milky Way. So it's a spiral galaxy. So you can see these dark dust lanes in this picture. And so those are some of the arms of the Andromeda Galaxy. And that's where the dust and gas lives in the spiral galaxies and the arms. And so that's where that active star forming regions are. And that's where stars are being made, planets, possibly extrasolar system exoplanets, and things like that. So that's where all that activity is happening, is in the arms. And then towards the center, there's not a lot of activity happening there. There's a lot of older stars, but there isn't a lot of gas. There isn't a lot of dust. And these older stars are really, really close together. And then towards the center, there is a supermassive black hole. So again, not a lot of crazy activity happening towards the center, but in the spiral arms, that's a lot of active formation happening. And so again, that really bright region that we're seeing, that is the center of the Andromeda Galaxy there, where that supermassive black hole lives and where all the older stars are. And then those kind of dark lanes, that is the spiral arms. So super, super cool object. Again, I recommend if you ever go to a place where you get really dark skies, so you can see the stars super clear, to get a Starfinder app and look for the Andromeda Galaxy, and you will be able to see it with your eyes. It's not going to be insanely bright, but it's going to look like a little smudge. It's so incredible to look at. All right, next up, let me see. So someone asked to see SN1671. We possibly might be able to see this one. It might be behind the building, so we're going to see if we can get this one. But it's a supernova remnant. So yeah, we're going to see if we can see this object. Oh, and I apologize, I forgot to talk about the interface that we're using. So as you can see right now, they're typing in SN1671. We have telescope operators that are operating the telescopes for us tonight while I talk about these different objects. And so that interface basically moves the telescope so they can type in just the name of an object, or they can point and click to the object and it'll move to that object, which I think is really, really cool. We don't have to do anything crazy fancy. We just type it out or point and click, and there we go. So let's see. Yeah, this one, it looks pretty dark in this part of the sky. At least it's not behind the building. Sometimes with these objects that are a little bit more faint, we have to get really long exposures. And then with those long exposures, we have to sometimes stack them on top of each other. So it could be a whole night's worth of data to actually see these objects really well. So we can see what we can get here with just a very, very short exposure that isn't stacked. But there might be that discrepancy here. Yeah, so it looks like we're getting some glow from the building possibly. And yeah, it just doesn't look like yeah, I don't really see it. That maybe is something there in the center, but there we go. At least we tried. Okay, so let's move on to something else. So Tom C asks, how's the sky looking at the moment? Any chance of looking at the Hins variable nebula, or the Hubble? Hubble? Oh, they're different ones. Okay, let's look at both. So let's look at the Hubble variable nebula, and then we'll look at the Hins variable nebula. I think I've actually seen, I can't remember which one I've seen. It looks like a little comet. So I'm super excited to look at these ones. They're really cute. They're really, really tiny. But yeah, the sky at the moment, I would say is pretty decent. There isn't, the moon is not up right now. So we got a nice clear sky. No clouds that I saw either. The humidity is pretty low as well. So pretty good night. Okay. So this is the Hubble variable nebula. And so, yeah, so I like this one because if you don't know that it's a nebula, I think it kind of looks like a comet. So it looks like there's a tail and that there's a little, comet there. But this is a nebula. And so it's really, really bright. So I believe this nebula is being emitted, is a reflection nebula. Let me see really quick here. But this is a really cool object. So let's see. Yeah, so it's a reflection nebula. And so this nebula, the whole reason why we can see it is because it's being illuminated by the star R Monocerotis. Monocerotis. It's in the constellation Monocero. So Monoceros. There you go. Okay. So yeah, I really like this object too. I mean, you'll hear me saying that a lot, but all the objects that we look at tonight are really cool. So let's look at the next one, the Higgs Variable Nebula. Let's try that one out. I don't know if I've seen this one. Maybe I have. And see, all we do is just point and click, and then we go to our object. And so while we move, let's see some other questions that we have. We have Gary asking, I'd like to see any planet that is visible. So we have one more planet up, which is Uranus. We could look at that one next. We already looked at Mars. So we'll look at Uranus next for you, Gary. And then we have another question from Tom Sarko asking, can you get galaxies M65 and M66 in the same field of view? So is that Bodes? Bodes and Cigar? No. Oh, the Leo triplets. Oh, okay. So the Leo triplets. I think we actually might be able to get them in the same field of view. We can try that tonight because it is a little bit darker. I don't think I see the nebula that's up right now. Maybe just a little bit around that star, possibly. Yeah, I'm not sure if I'm saying this one too much, which is okay. At least we tried. So we'll let this exposure load up here, and if we can't see it, then we'll just move to Uranus. Okay, so yep, it doesn't look like we can see this one. It's just a little bit too faint. And again, we're taking really, really short exposures. We're not stacking them or doing anything crazy with them. We're just doing really quick 20-second exposures. So yeah, let's move to Uranus. So that is the only other planet up tonight. It really just isn't planet season anymore. Around fall, we had so many planets up. It was super, super crazy. We had the Great Conjunction, you know, Jupiter, Saturn, Mars, Uranus, Neptune, even Pluto was up. So there was lots of planets up. But we're getting into Venus season here. So early in the morning, you can see Venus. All right, so here is our planet Uranus. So it's our little blue, pale blue dot. So a little bit different from Earth's pale blue dot because there's no water or anything on Uranus. But Uranus, the reason why it's a pale blue dot is because of the composition of its atmosphere. So Uranus has a bunch of methane and ethane in its upper atmosphere. And when we bring up the exposure, we can actually see the moons of Uranus. And so those little tiny specks of light, those are some of the moons of Uranus. And so Uranus and Mars and most of the planets actually have history with Lowell Observatory. And so we actually know that Uranus and all the other gas giants have rings around them, but the partial discovery of the rings of Uranus were done by an astronomer here at Lowell Observatory, Larry Wasserman. And so I think that's really cool that we have connections with most of the planets here at Lowell Observatory. Okay, so there is our little planet Uranus. It's not actually little, it's really big, but it looks little. So let's get to Tom Sarko's question and see if we can see the Leo triplets in the same field of view. So again, this is a new camera. So we just got it just a few weeks ago, not even. So with our old camera, it was a much smaller field of view. So I don't know, I've never tried it with this new camera, so we will see what we can get with this one. So this is the Leo triplets. So it's a cluster of galaxies in the constellation Leo, or that's why they're called the Leo triplets there. And I like Leo because it has a lot of galaxies in it for one, but also a lot of the galaxies are named like really funny things. Like I think there's like the onion galaxy and the hamburger galaxy in Leo. So I think that's funny. Oh, and it looks like we can get two in the same field of view. So we have this function with our telescope where we can actually jog it. But when we're taking these exposures, it's kind of time consuming to jog the telescope around, but it does look like if these are M65 and M66, it looks like they are in the same field of view. So that's really cool that we can get that with our telescopes. And so if you ever want to spend more time and see if we can get this, head up to Lowell Observatory during our premium access events and we'll be able to get it for you. So really, really cool. Let's see what else we have. We have some requests also from Tom for different clusters. So let's see. M79. So let's try M79. So it's a globular cluster. So we'll see if we can do that. So while we move there, let me go over some other requests here. So someone asked if we can see the moon. Madonna asked, can we please look at the moon? In Phoenix, the moon has been extremely big the last, the comment cut off, the last few days, I assume is what it says. So no, unfortunately, the moon is not up right now. So when you see, the moon has been at full moon, I think, for, I think it was like last night or the night before that. And so the moon is starting to rise a little bit later each night, I believe. So tonight it's going to be rising a little bit later, and it's not going to be up while we're doing our event, or it's rising while we're doing our event. So unfortunately, we won't be able to look at the moon, but if you ever want to see the moon on a good night and you plan your visit correctly, you can see it here through our telescopes at the Giovanni Open Deck Observatory during our premium access. Okay, and then someone else asked if we could look at Delphinus. And so unfortunately, Delphinus also is not up. And then someone else asked to see the Hyades. And so the Hyades actually it's an open cluster, but it's also the constellation Taurus. And the Hyades is too big to see with our camera. So our camera, again, has a smaller field of view. That's why you can see these really tiny nebulas. All right, so now it looks like we have our globular cluster M79 here. Okay, so with these stellar clusters, we have two main clusters. We have globular clusters, and then we have open clusters. So globular clusters are old stars that are clumped together in a glob. That's why we call them globular clusters. And we actually think there's more evidence that shows that these were their own galaxies, or dwarf galaxies that were passing by the Milky Way that we gobbled up and took into our orbit. And so that's not for sure proven. There's still a lot of work going into these globular clusters, but the stars in these globular clusters are around the same age of our galaxy. And so that's why we think they were their own little galaxies trying to be made that the Milky Way kind of took. And so they're really close together and then really not going anywhere compared to open clusters. So open clusters form in stellar nurseries in these big nebulas, and they're very young stars. And so those stars, when they're forming in that stellar nursery, they will eat up all the gas and dust, and then there won't be any more left. And then we get this cluster of little baby stars that eventually will start to interact with each other and tug and pull on each other and like push each other away, and they'll spread out and become this open cluster. And so they're very, very young stars that are made in stellar nurseries. So that's a really pretty globular cluster there. So since we talked about it, let's look at an open cluster. So let's look at M46. And so this one says it has a planetary nebula inside of it. So we'll see. So while we're moving this, we'll get to some other requests. So someone asked for Alcor and Mizar. So unfortunately, that is behind the building. So the Big Dipper is behind the building. Alcor and Mizar is a binary star system. So yeah, we can't see that one. Someone asked also for the moon, the snow moon. Yeah, unfortunately, the moon is not up right now. Someone also asked for Pisces Austrinus. Unfortunately, that is a constellation, so it is not up. Well, it's a constellation, but it's also not up, so we can't see that one either. Okay, so now we have our open cluster M46 up right now. And yeah, this is so cool. We have a little tiny planetary nebula in it. And so I was saying earlier how, there isn't just stellar nurseries as nebulas. There's different kinds of nebulas like the reflection and the emission. So this one's called the planetary nebula. The reason why they're called planetary is because when people were looking at them, they thought they looked like little planets, but they have nothing to do with planets. They actually form when smaller sized stars, so a star maybe like the size of our sun, when they die, the outer layers of the star, they'll start bigger and bigger, and eventually gas will just kind of drift off. And so we don't think it's very uniform. We think there is, different dynamics and shapes that can be formed. Right now, there's this theory that it's kind of cylindrical. And so it's like a soda can. So this one looks like a little ring. So we're looking down inside the soda can. But there's other ones that are like sideways where you can see it like the side of the cylinder here. But that's a really cute little planetary nebula in our open cluster. And so all those stars are part of the open cluster. And so also, so this one, is it in Cassiopeia? But Cassiopeia is a really, really awesome constellation for these open clusters. If you are an amateur astronomer or you're getting into astronomy and have a telescope and you don't really know what to look at, if you can find the constellation Cassiopeia, it's in the shape of a W or an M, whichever way you're looking at it, and just point your telescope there. Anywhere in Cassiopeia, there's this whole field of stars. It's just stars for days. So it's a really, really beautiful piece of the sky there. Okay, so let's see what else we got. So let's try the Pleiades. So someone asked for the Pleiades. So yeah, the Pleiades actually is still too big of a field of view for our telescope, but we can try to get some individual stars that are in the Pleiades. So there's this one star in the Pleiades that actually has like nebulosity around it. It's not actually around it. The Pleiades is kind of like passing through this nebula. So it looks like it's around it, but it's not. But yeah, we'll try to see. So they're looking for the Pleiades right now. So while they're looking for it, let me get to some other requests that we had. So someone asked to see Zenith in the Sextans constellation. So Zenith actually is just like a point in the sky. So Zenith just means straight up. So if we look straight up, I mean, we could do that, but there isn't really anything interesting to look at, and it changes. So that's what that means. Puppis, is Puppis viewable tonight? It might be behind the trees. We could try it, possibly. NGC 2451 is in it, which is an open cluster. So we'll try that maybe. And so someone else asked, can we see the Hamburger Galaxy? So the Hamburger Galaxy is NGC 3628. So it's actually one of the Leo triplets. So we already looked at it. So if you go back, there's the Hamburger Galaxy. Yeah, again, really funny names. And so on the screen here, we have some really bright stars. So these are some stars that are in the Pleiades. I could not tell you which ones they are, just because when we move the telescope, we just kind of like point and click to it, and it just goes to that region of the sky. So, but those are some of the young stars in the Pleiades. So the Pleiades is an open cluster. Again, very young little baby stars. So super cool. So let's try to do like one more object. Let's try to do the Pinwheel Galaxy. And so this will be our last object for the night. Someone else asked for the butterfly cluster, and unfortunately the butterfly cluster is not up. And then someone else asked for the Horsehead Nebula, and the Horsehead Nebula we can kind of see with our telescope. It's in Orion, but it's pretty faint with our camera, so it's going to take a really long exposure to do that. But I think we looked at it just a few weeks ago. Someone's asking, how far can this telescope see? And so while we wait for this picture to load, I think it's kind of a relative question about how far this telescope can see. So we can see galaxies, you know, that like this one, the Pinwheel galaxy, we can see them and they're millions of light years away. And so it's just kind of a relative question, and it depends on like the brightness of the galaxies, and it depends on, you know, how big they are, how close they are. So, you know, technically we can see millions of light years away. And so this one's several million light years away. You know, like Andromeda was like 2.5 million light years away. So, you know, we can see pretty far out there. And yeah, so the Pinwheel galaxy here, again, it's another spiral galaxy. So it's a lot easier for us to see spiral galaxies compared to elliptical galaxies. So there's all these different types of galaxies. The main ones that are pretty are like spiral galaxies, or like starburst galaxies. And so you can see our spiral arms there. There's two main prominent ones going up and down, and then we got some kind of looser ones going around there. And so again, you can kind of see some gas and dust in the spiral arms. And then right in the center, it's really, really bright. That is the core of the galaxy, and that is where all the main activity happens. Or that's where the supermassive black hole is, and all the main activity happens in the spiral arms. Okay. So, yep, I believe that is it for tonight. So if we didn't get to your object tonight, don't worry. We do these every single Tuesday as long as the weather is good. So for the month of January, the weather wasn't all that well. We had lots of snow in Flagstaff, lots of clouds, but as spring approaches here, the weather is going to get a lot better. So we'll have these every Tuesday as long as the weather permits. And also don't forget, we are having our Messier Marathon happening next weekend, I believe, March 13th. The night of March 13th. And basically what a Messier Marathon is the Messier catalog, just like I was talking about a little bit earlier, has around 100 and something objects in it. And for this event, we'll be starting around 5 o'clock in the evening and going until 5 o'clock in the morning, looking at every single object in the Messier catalog. So we'll go to all 100 objects. And so it takes all night is because these objects are in different places in the sky, and so we have to wait for the Earth to move and show us all these different places so we can look at them. So it's going to be a crazy event. It's going to be, you know, like a 12-hour long stream. It's going to be ridiculous, and it's going to be so much fun. So definitely tune into that and mark that on your calendar so you don't miss that out, because, you know, again, if we didn't get to your object tonight, we're definitely going to be able to get to those Messier objects during the Messier Marathon. So be sure to tune in for that. And if you don't want to stay for all the 12 hours, it'll be recorded and uploaded to your YouTube channel as well. So if there was something that we saw earlier and you tuned in a little bit later, you can go back in time and see it. But yeah, thank you all so much for staying here and looking at all these cool objects with me. I had so much fun, and I hope you guys enjoyed it. I hope you guys have a good night, and thank you again for tuning in to our interactive stargazing.